Paul, tell us about this new technology called Envirolastech. How did it all start?
Back in the early 90s, I owned a couple different construction companies. I was a general contractor. One of them, primarily EBC Inc., Equestrian Builders and Consultants. We did a lot of large animal confinement, a lot of horse barns, pasture scheming and the such. I was asked to be involved in a feasibility study for the University of Minnesota with the Minneapolis Mounted Patrol and the City of Minneapolis on a new staging area for the Mounted Patrol in a couple different areas. The thing that they really wanted from me was to help design the inside of the stall, see if there's any new products on the market out there. So basically with horse stalls or cattle confinement or anything, when you're bringing them into a vet hospital, the viruses can live in the wood stall for a day, a week, and many of them can live there for years because you can never really sterilize wood. They have been using concrete, but concrete is a very rigid wall, and large animals are inherently claustrophobic by nature. They're a herd animal. So there was some injuries to some very expensive animals over the years, and they wanted to eliminate that if possible. So what came to mind was recycled plastic boards. They were just coming onto the market. The technology was new. It was something I could use for my business. So I started investigating several different companies. And one of the main leaders back in the early 90s was a company up in Green Bay. Met with their engineers and their process engineers, learned a lot about recycled plastics, realizing that recycled plastics have rigidity problems, flexure strength problems. As far as being sterilized, they were awesome. You could do it in 15 minutes. But they wouldn't work for a horse stall, especially large animal confinement. So over the next 8 years, I visited multiple different extrusion plants, injection molding plants that were starting to use recycled plastics and actually inventing the new technology, a lot of it is what we see today, like in your decking. I had theories using mineral fills. The problem with the mineral fills is they had some inherent weaknesses along with the inherent weaknesses of the plastic. We couldn't get anything close to matching lumber. I started developing theories about the possibility of linking the different multiple recycled plastics together. Instead of just using one or two, being able to actually link 3, 5, 7 of them together to develop technically a new plastic. And then the mineral fills became a filler. And being able to control the physical aspects like the brittleness, flexure strength, being able to match lumber, exceed lumber. In some instances, in some products, we actually exceeded concrete, like in retaining wall blocks or seawall blocks. So the inherent weaknesses of recycled plastics, like flexure strength, brittleness when it gets colder, we learned how to control expansion and contraction, how much from high temperatures to low temperatures in your environment plastics does expand, being able to control that. After all these theories that I had, I couldn't find anybody to run them because one of the minerals I wanted to use, amongst others, was fly ash. Large quantities, fills up, makes 40 to 60% of our landfills, over the last 100 years. And fly ash is nothing more than purified dirt, but it's extremely abrasive. It comes from our coal burning power plants. So I ended up having to actually build myself a research lab. Back in the late 90s, I sold off my construction companies, built myself a research lab, hired in some engineers, plus with all the technical support I had around the country. We developed the first structural plastic lumber made out of recycled plastics. The flexure strength, for instance. The highest really anybody's been able to achieve is about 400,000 psi. Wood sits between, like a wood stud will sit right between 800 and 900,000 psi. Well, we achieved 1.2 million. We kind of just stopped there because we had already exceeded the ASTMs of the wood, and we just kind of followed through. Thermal expansion and contraction, we were able to control that. It was the first plastic part, as I know, that we actually gained in strength as it got colder. So at 70-degree temperature, if we had a compression modulus of, say, 3,400 psi, it would be 1.5 times that at -30. So we took out the brittleness factor of recycled plastics when it gets colder. And all this technology was developed in that lab over the next 5 years, right down through the processing techniques. We tested out and built and developed over 30 different products. you know, and just then we went into our long-term field testing, which we have just basically completed. And the primarily products were like different fencing and decking products, a few siding products, and just to see what happens in the environment, because artificial aging and artificial color fade and all that can be done in a lab, which we did, but it's nothing like the actual, especially in the Minnesota climate where we can have a 60-degree temperature change in a day. So that's where we're at, and that's basically where it's come from.